jump in. So units, not Unix. I'm sure like we have heard these things before, like see you in 5. It's 21 outside. It's freezing. But what does that mean? Like see you in 5 what? Hours, minutes, seconds? 21 is what outside? I mean, if it's Celsius, it's good. If it's Fahrenheit, we have a problem. I can run a 5K in 30 minutes. Kilometers, that's respectable. Miles, now that is good. So I mean, that's just my pitch of like, no, units are kind of important. And if you don't take anything away from the talk, but I just want you to take this one thing away from this talk is that think about units. You don't have to use what I like show off here, but just think about units in your data. Like whenever you're working with data which does have unit, don't just drop it. So just something to think about. All right, but before we jump in, let's talk about some whoopsies of what happens if you're not thinking about units. So this is a famous example. It's pretty old. It's from 1998, where the Mars climate orbiter, it crashed. Why? Because one of the defense contractors did things in freedom units, and NASA was expecting it in SI units, which the software spec was like, that's what it's supposed to do. And it was $500 million, a lot of money. So, units are important. Another example, so luckily no one was really injured in this, but I found this example where when they had they had this a ride, Space Mountain in Tokyo Disneyland, and the initial drawings of the thing was in I think imperial units, and then they changed to metric units. In conversion, some rounding errors happened, and then the axle was too small, too big. So units are important. And then there's another example where someone had to do manual calculations because the thing was not working to which measures how much gas you have in the plane. I don't know how to say that, but they used the density in a wrong way. The density was given in pounds per liter, but they used for kilograms per liter. So, and they ran out of fuel in halfway, and they had to glide down, and they were able to land. So think about units, and don't ask me too many questions about this. Just that do not mix pounds and grams, especially when you're cooking cookies or desserts or anything. And if you refresh a website, sometimes even if you move from imperial to metric units, it will go back. Just for your information. All right. So now that we know the whoopsies that can happen, let's talk about the scientific Python world of units. What do we have here? We have a lot of that. And it just goes to show that everyone has their own way of doing units, because it's a matter of taste. People have different ideas how they should do it, and it honestly does not matter, in my opinion, how you are doing it. Use any of these packages. So I'm just listing some of the ones that I know of. There are a lot more. I know even SciPy has some units in them. So you can use Python quantities. You have Pint, and Pint even plugs into Xarray, so that is nice. And the one below are C++ ones, but and if you're writing some C++ code which has Python bindings, you can use Boost units, you can use LLM units, and you have a lot of options. This is how they usually look like. I have different examples. You have Pint. It will tell you if you multiply meter and add a centimeter to it, what do you get? These things. So it does the conversion for you. It will also stop you if you try to do things if you add velocity plus 3 what. So and also that's the other annoying part, that every single unit library would have their own, gotchas. Like some would allow certain things, some will not allow certain things. So irrespective of that, if your data does have units, please use one of these libraries to when you are modeling or loading or analyzing your data. And with that, there's also a discussion later on, like in the maintainers track, where there's this new project, Quantity Dev, by Lucas and other people in the community, where they're trying to standardize like how units. I mean, it's like array API, but for units. So I mean, it's just a discussion at this moment. So if you are interested more in like how this could work, is how you have the chance to like design the future of units in Python. So if you want, you can drop by there at 4 p.m. and you can help brainstorm some ideas. All right. So hopefully by now, all of us can agree that we should not skip units. Yes? Yes? Yes. So if you have agreed to not skip units, lest you skip. I mean, you can call it, like people call it SciPy. It's fine. It's supposed to be Science++, because it's C++. And but anyway, let's call it skip. And the skip is an open source package. It's mainly developed by ESS, where I work, the Open Installation Service, and it's our take on having like multi-dimensional data arrays with all the niceties of having physical units just next to them, having like label dimensions, having like if you have uncertainties in your data readings, then you can keep them, and like if you do any arithmetic operations, those uncertainties will be propagated with caveats, but we have all these things inbuilt, and this would look a lot like Xarray for people who have used Xarray, but with like some more special sauce on the top. But one thing I do want to show off is it says NumPy like. It's not actually NumPy underneath. For example, Xarray builds on top of NumPy. We have our own, just like C++ vectors underneath. So for like certain performance reasons, we wanted to have we ended up creating this instead of building on top of NumPy. But there's still theoretically possible to move data from skip to NumPy without a copy. So you have that. So let's quickly look at some code. So, and also I'm not trying to diss on NumPy here. And as you can see, this is a demo. Do not believe this. And I put like 1 billion random points, and I create a NumPy array with 1 billion random integers, a skip array, and an Xarray variable. All right. So this is how it's like 1 billion points, random 1 billion points. So I hope this actually works. All right. So let's do skip array. I'm just taking very simple operations like mean of 1 billion thing. It takes 66 millisecond, and with NumPy it takes 500 millisecond. The reason for that is that skip underneath is doing multi-threaded for everything. It uses TBV from Intel, so it's for certain operations it's a lot faster. And especially in our use case, we had to worry about this because we'll be doing a lot of live data processing. So it needs to happen quickly, certain things. And Xarray uses NumPy, so it is bound by that. And there are some other operations like histogramming. That's something that we would need to do a lot of. So it takes 3 seconds, and I think it will take 10 seconds or so for NumPy. Yeah, 9 seconds. All right, so let's jump back. So that was just we're not trying to replace NumPy here, just to be clear. It's just for certain operations. if you want speed for if you want multi-threaded code for certain things, it could be a good library. And also this only works if the data is big enough. If you go to 1,000 points, it will actually be slower. So just to point that out. Alright, so for people who already use X-ray, I don't need to sell you on this why labeled dimensions are good. So let's say I have a very important database, some data set, which is, let's say like I have longitude, latitude, and altitude, and that, and let's say it's a plane or a helicopter or some drone, and I have like speed at that. And let's say I want to find the average speed at a specific altitude. Let's say this was in a NumPy array. How would you do that? What's the index? Which one is it? Is it the first one? Wait, where does the I go? Wait, which axis am I trying to mean over? So these are the problems that you can solve if you have labels on your dimensions. So, usually my answer would be I'll just look at the shape, because ideally it will tell me which axis is what, because hopefully it's not 100, 100, 100, but sometimes it is. But both X-ray and because we basically copy a lot of X-ray's API, and it's not a drop-in replacement, but it's more in we try to be as close as possible. So you can basically just give it these dimensions, and it becomes much easier. Opinions, but I think going to this data set and be I want this altitude I, and calculate the mean at this altitude. So this is why maybe you should think about label dimensions, especially if you if you have this tabular data, then it's fine. You can load it into pandas or polars data frame, works fine, and it has its column names. But especially if you have multi-dimensional data, 3, 4, 5, 6 dimensions, it gets annoying super fast. So something that could be useful. And that's again for people who know X-ray, this is the same exact thing like X-ray. It's you can also add more information about the coordinates. If you go back, the only information we had was the indexes 0, 1, 2, 3. But what does latitude 0 mean? So you can add that information, for example, from 120 to 120. It's just a grid that you can add. And if you look at the data right here, if you look at the data right here, it tells you something about it just create a linspace for that. And but you may ask, I was going on and on and on about units. There are the units, and with longitude, latitude, and altitude, there are units. You have degree there. You have meter or feet for altitude. So we can add that. That's the the fun secret sauce there. So we can add unit. You need to find the Unicode for degree, or you can just write DEG. It's fine. It's very smart. It will figure it out. And they show up right here. And even for speed, I actually ended up adding a unit, so meter per second. So the units are very, very, very close to the data. So it's harder to do things that you should not be doing then. You can still fix them, but you catch your problems earlier. That is what I'm trying to picture. And with all these niceties, we also get some more fun things. Just like we have SciPy, we have plot++. It's plot, and it's it's a wrapper around Matplotlib. You can choose a backend, Matplotlib, Plotly, or Py3.js, especially because we have a lot of 3D visualization in the browser that we need to do. So, and if you will see, it comes with all the niceties of adding the units to your to the axis, so degree, and meter second. So it spits out images that no reviewer would be oh, where are the units? So it helps you with that. So that's the 3D thing that you can do with Plop. Just a quick shout out to Plop. But yeah, enough screenshots. Let's look at some energy. Alright, so all of us know E is equal to mc squared. What does that mean? It's the mass energy equivalence where famously you can convert energy into mass if you have the Higgs boson thing. I don't know if you have it. But yeah, so let's speed of light. This is the number that I got from Wikipedia. I don't know if it's still true. But yeah, like right now these are just like Python floats. That's it. Like it's just like a float number with a long number and a mass. And let's try to find what's the energy equivalent of 1 kilogram of mass. We say this was supposed to be after that, but I mean it's some big number. What does that number mean? What does it mean? I mean, like if you like this is what it means actually. I mean, like, this is the unit for that number: kilogram meter square divided by second square. That is what energy is apparently. If you just do the thing, but this is something that we need to keep track manually. We need to do this, and what if you make a conversion somewhere only? Oh, I need to divide it by. What if it was not kilogram? It was actually grams. So it's very easy to like. I mean, these are like stupid mistakes, but it's very easy to do them. And it's easy to catch them too, but sometimes you have wasted a lot of time debugging that mistake. So that's what we are trying to prevent here. So what instead we can do is, we can take these scalars and we just tell it like meter per second. That's the speed of light and that's the unit. Same goes with mass. And if we calculate energy now, it gives us this thing J, which is joules, and like joules is the same exact thing as kg meter square by second square. So it keeps the unit next to the data. So even if you, for example, go change from 1 kilogram to 1 gram, if you do this, I should not have done that. Wait. See, Jupyter notebooks. Need to restart. Yeah, and and then you can like there are some inbuilt functionality where you can just change units because sometimes if you're in certain research fields you like to work with electron volts for energy. You don't want to work with joules. You can convert that. It will give you another big number, but like they are the same exact thing, but you don't have to manually keep a track of it. And if you convert it to petajoules, it looks like a better number now. It's like 89.88 petajoules. That is the thing that if you Google like what's the equivalent of 1 kilogram of mass, that is the number, 90 petajoules. And just like I was claiming, that they error out early. So like for some reason you're trying to remove some mass from energy, it will give you an error that you cannot subtract joules with kilograms. So it will force you to think before you do these things. And same with like if you try to add them. So these operations are they error out quickly. Let's say if you do like mass multiplied by mass, I mean it will let you do like kilograms multiplied by kilograms. I don't know what kilogram square is used for, but it will let you do that, and you would know that you did this multiplication somewhere in your analysis, and because you know the unit. And any ideas what would happen here? Like I'm doing like two scalars. Like one is Armstrong, which is still a unit of distance for at atomic level, and 1 kilometer. Any guesses what could happen here? What would this distance 1 plus distance 2 give you? 1 kilometer. No, it will give you an error. Because, and this is where some units library will let you add these things, but like one of the things is that like Armstrong is fine. It's a distance of unit, but it's like 10 to the minus 10 or 12 or whatever. So sometimes you lose precision, and that is not something you want. So the idea is that you should do these things if you really want to do this. So like you need to convert Armstrong to kilometers, and fine, it will give you like 1 point, a lot of zeros to 1. So that's the Like that's what I'm trying to pitch here. So if units are next to your data, irrespective of how you get that units next to the data, it forces you to not do these mistakes. All right. Can we wait till the end? Sorry. And skip builds on top of, like, we don't do the unit conversions. It's a library in units, C++ runtime library, and we build on top of that. So if you want to change something in skip, you actually need to change something in units. All right. So science can also be uncertain at times, and that's the other nice thing that I like about skip is. Let's say this is the formula to calculate the dew point given temperature and relative humidity, and let's say your sensors actually have some sort of variance in it. Like fine, it give you a reading, but it also has something that this reading is plus minus 0.1 or something like that, which is usually the case of sensors. Like they'll tell you, like in the spec file, like it has some variance. So with skip, what you could do is you can basically like create like a scalar. Let's say 22 degrees Celsius. That's the temperature outside, but the thermometer I have has a variance of 0.1. So let's add that. Even the sensor that is measuring relative humidity has some variance in it. So what it would do is it will calculate the new number, like the dew point, but it will also give you this, like the variance in the standard deviation of like what is the calculation. It won't just give you out the number. So like it helps you keep this uncertainty in place. And also like this comes with a lot of caveats. Like it assumes that there is no correlation between like these different things. So like okay, read the talks before trying to using this. And so that, and the other thing that is used a lot, at least in like neutron science, is you get a lot of these event data that is just like a bunch of points on, like, let's say, a detector, and you want to histogram that and quickly. So you can do this thing where, like, let's just make because this could be like a billion points, and you don't want to point out plot out a billion points every time, because that's slow. So you can do like quick histogramming, and let's say this is what you actually want to see. Like you don't really worry about the tiny points, but you just want to get a feel of the picture, what is happening, and you can decide like how much resolution you want. And I mean, like the whole point is of skip here is to make these certain plots quicker to plot. You can do the same exact thing with NumPy, matplotlib. You will reach the same plot at the end, but it's about reducing the amount of code scientific users have to write to get these plots out. And I'll actually just quickly go through this. The other thing is binning. So binning comes before histogramming, and for us it's a major thing because we want to still keep the data around. Like as soon as you histogram, you're doing some operation on that bin. But we want to keep the bin around and do operation on individual bins. So skip does come with this nice way of doing binning and doing operations on that, and you can you can use that. We have nice talks about that, I hope, and you can go read that, or you can just talk to me later. But yeah, thanks. So I hope that irrespective of whatever. Like if you use skip, NumPy, X-ray, does not matter. I just want you to keep this in mind. Units. Like I hope this is the takeaway from the talk. That I mean, I'm guilty of that. Like I never cared about units. I just that's the thing that you would put in your paper at the end when you're making the nice pretty picture. Need to add Kelvin, but it's a nice way of life where you're like, oh no, that's not something that you think about at the end. But from day zero of your experiment, so it's something nice there, and you can learn more about skip. That's a website. It's an open source project. We have a user guide, which like I would be honest, like a lot of that would be a bit more domain specific for neutron science, or even like so if you do find a better use case or better example, please feel free to like submit a notebook where you're using this for other things. So that's fine. And yeah, contributions welcome, especially if you're someone who likes the word Conan, CPM, PyBind. If you like these words, please talk to me. I'm stuck with certain things. So yeah, thank you.
So we have time for a few questions, and in the meantime, I would like the next speaker to come forward slowly.
In your example with the angstrom, if that was a meter,
it was still it needs to be the same exact. And that's a choice. Like we have an open issue where we are like, what should we do here? Should we try to because for example, Pint actually will do the calculation for you. It will, I think, takes the first operand. So it's a choice that we're like, no, let's not do that.
Yeah. My other question: what happens if you create an actual cookie disaster?
I don't want to talk about
that. Does Plop also handle the uncertainty and add the error bars?
Yes. Yeah, it will add like nice. I mean, but like Plop does have some. Like for example, not everything would work in 3D, and like even the 2D, like the uncertainties will only show up if you have the 1D plots, because I don't know what's the best way of putting uncertainties in a 2D like heat map sort of thing.
Right.
So I mean, if you find a use case where you want, like then we can add it.
Thanks, it's a great talk. I'm a big believer in units too. EuroSciPy has a wonderful decorator called quantity input that will allow you to use type hints to make sure you're providing your function with something of an equivalent unit.
Yeah.
Have you got something like that?
I mean, I don't know how. I mean, it's hard to make scientists people write type hints. So, I mean, like it is a lot of our code is typed, so it will like tell you those things, but we don't have like types at the unit level. It's more like, oh, it's a data array. It's not like a data. It's not like a data array of meters. That's not the case.
Okay, most of the units actually use the international system, right? But what happens if someone wants to use like Gaussian units or natural units? I mean, because in Gaussian units, for example, you don't have a fundamental unit for the current, so all electromagnetic units are all different and not just. Do you have support for that?
I mean, if something is missing, we can always add it to LLM units. So it just need to be added. Like we don't have support for all the single units, but like things that we have tested, yes.
And what is like if you change the unit system, the same units have different relations between one another, and that's the problem.
I don't have a solution, right? At least right.
For example, if you put some physicists put the speed of light, they claim in this for simplicity, they say, okay, speed of light is 1 unit less. At this point, time and space are the same unit. So sometimes it's rare, but it can happen. Okay, thank you.
I'll ask the Bureau International de Pro Emergence. They are the ones responsible for SI units and then reason.
Yeah, so now we have 5 minutes break. If you want to stay here, stay here. If you want to go to another. And
Oh, that's nice. That's good.
But that's before the first minute of the Q&A.
Okay.
You can take the 5 minutes of Q&A for presentation, but then you will not have the Q&A.
Okay.
So, but after that, you just
Yes.
So
Yeah?
when I show into the time zap card, you don't have to know stop talking and exit. You just need to stop the presentation
I will.
in like a minute or maximum 5 minutes.
I will.
Yeah. And also some smaller technicalities. Your name is Oliver Segeman.
Yes,
So the pronunciation is good.
it's good. Yes.
Here the connection. You can just take the HDMI.
Maybe that's easiest, right?
Yeah.
Push it there.
Because if you take with this, then you have this.
Oh, I have
go
this?
through the- you have your own. Okay,
Yes,
that's
yes.
perfect.
It's also like a laser pointer, so I like it.
Yeah. Okay.
And which microphone should I use? Should I use the hand mic? Is it better?
Yeah, hand mic. Don't use this one because it just creates like some statics and generates problems. Use this mic. I will announce you, then I'll give you the mic. You have a different
Perfect.
microphone for questions. Do you need a glass of water or something?
No, thank you so much. That's really nice.
Okay.
No problems. Now I have 3 minutes left of like.
That's good.
I like your introduction into scikit-learn the other day.
Yeah, thank you.
I was quite familiar, but I'm really bad at teaching people.
Yeah.
Like, what would people need to know? So that was really helpful, and also your slides. Thanks
Yeah.
for saying. Yes.
Yeah, also thank you. So I worried that it was a little bit too basic. I teach students this, but students from business courses, so I need to really water this down.
So for me, I understand it, but I needed that kind of like the approach to tell other people who are maybe not so familiar with it in my company. So for me, it was very helpful.
Yeah,
Yes.
I'm happy to hear it.
Yeah. Also very beautiful slides.
Yeah, thank you.
Nice slides. Yes.
Okay, so we have 1 minute left, so we'll start with the introduction. The next speaker is Oliver Segeman, and Oliver here has been developing software for 40 years, progressing from assembly language to C then Python, and ultimately to machine learning. Currently, he works at as a machine learning engineer at Technica Krankenkasse. Yeah. Perfect. And here you have the title, Routing Strategies for Heterogeneous Gen AI Systems, Lessons from Real World Practice. So I'll give you Mike.
Thanks a lot for the nice presentation. So that's a very long title, but I guess you will understand what it's about in a minute. So first of all, what is LLM routing? So LLM routing is deciding which model, which AI system, which data flow, which entity should handle a request. So probably what you thought maybe. So who has ever used an LLM for anything? Okay, that was a really bad question. Who has never used an LLM for anything? Okay, really silly questions. But just to make sure. So I think we are all on the same page. You might be in the right session. So the work that I presented is actually, we had a post yesterday. It's work by my colleagues Arne and Marcel and myself. And this is like the extended version. I'm happy to talk after this thing because probably you will have a lot of questions, or maybe you don't. But if you want, I'm available. So why would we do this? So this is our use case. But first, the technical account castle, that is like the largest by number of insured members health insurance provider. Which might be surprising. You might ask, what do you want here? I mean, why are you doing this? But you will understand. So we have medical assessments which are sent to us by partners, and some of them, this is one of the use cases, we have many, some of them, they contain oxygen. And oxygen, if you need the supply of oxygen as a patient, you need, it has to be handled quickly, for one, and then you also need to extract additional features from such a medical assessment. So it needs to be handled by a different system. And it needs attention. So what we had to try this out is we have an imbalanced auto-labeled data set, auto-labeled by an LLM, but then validated by humans just by checking the real-world answers. This is how it looks like. Let's see if I get rid of this thing. Yes. Horrible, right? I mean, but that's practically what you get. I was in the workshop of imbalanced data sets. I know you close to fainting, I guess, because these are really, really small numbers of data. But this is what we have. This is what we have to deal with. So that means the training set, 50 samples are not concerning oxygen, 22 concerning. Then we have the separate test set, which we try to handle properly. Then 21 of them are false, 10 are true. So keep this in mind when presenting the results, because obviously that's big limitation. So now, how do we do this? So we tried a couple of approaches, those 5, and I will go to detail with each of them. So first, a small language model. We're not quite sure about the terminology here. What is a small language model? But I will tell you in a minute. So first of all, it's medical data. You don't dare to send it into the cloud, because it's medical data. It contains your name, it contains all of your diseases and things, and all the cloud providers that we can use currently are either US companies or like daughter companies of US companies. So we don't dare. So we have to do it on-prem. That means the model that we chose is an on-prem model. It's a small number model. 3 billion parameters, that's really not large. That means it can run on inexpensive, in terms of large company, A100 GPUs. It still costs a few $1,000s, but for us, this is really not expensive. They're fast, but medical documents are complex, really hard text to get through, long and in German. So unfortunately, they don't perform well. They miss some cases. And we have that's really big. We have a confusion matrix, and we have for all of the approaches. In this case, the important part is this one. That means the true label, so it was oxygen, was predicted as false, which is not good for us, because this is the most important thing. So special data and attention was not given in 30% of the cases. And that's not good. Still, giving the very small amount of samples, maybe that's not quite accurate, but 30% we cannot do it. Then, hopefully you can see this well. This is the real code, because we wanted to show you like how complex is this. Unfortunately, it's German because it's real code, but you will see some interesting things. So it's Python. It gives a Python object back. This is the medical document X. This means basically, what are we doing? This is the question: is this a oxygen thing? And we give the grammar of the answer, and then we force the whole thing to generate a JSON that fits this the structure of the answer. And this is nothing fancy at all. This is what everyone does more or less. So we get back a Python object, which is very convenient, but also not something we could brag about. This is what everyone can do. So this is a Python object again, because it's the real thing. It's German. What this means is it oxygen? And then you describe what should be in here, true if it has oxygen, otherwise not. And you get a description why the thing thinks it is oxygen or not. So that's what we code. When you look at it, it always, like the prompt always looks extremely simple. And you think, yeah, that's obvious. But it took us a long time to actually write the code. It's very easy to read, incredibly hard to write. And no one believes it, but it's true. So now, with the same thing, we did it with the large language model, and our large language model again, Llama model, large one, 70 billion. We cannot use Llama 4, unfortunately, which should be stronger and multimodal, but we cannot use it in AE for legal reasons. I think it's copyright and horrible things, but we must not use it, unfortunately. It runs on two H100 GPUs, the expensive one with 96 gig each, and that is very, for a health insurance company, extremely hard to run, because we are a health insurance company. We would love data centers who could run it for us. We don't have. We do it ourselves, which is part of the problem. We use TGI inference server from Hugging Face, also something that's very standard. It allows for batching, and because of that, throughput is acceptable. Latency sometimes is not, but it's still our gold standard. This is incredibly good on everything we do, but it's a scarce resource, very expensive to use. Also very expensive in terms of energy. So if you put this in your compute center, you don't only have to deal with, like, you have to buy it, but you also have to have like completely different power supply for supplying it with power and then getting rid of all the heat. It's hard to run, unfortunately, but it's perfect. So it does everything right. We have not seen, even in production, we haven't seen a single failure. So this is really good, but also very expensive. Next approach. Supervised learning setfit. Who knows setfit? Have I used it? Oh, okay. That's good. And you learned something, maybe. That's good. So we trained on 75 samples and used for evaluation 50. So this is our complete train set, split it for training evaluation set. And setfit is a training method that can deal with only a few samples. So it should, in theory, work with this thing. So the idea is you use a base model, in this case this one, because it speaks German, and what you do, you create embeddings from all your samples. And in embedding space, you retrain that model so that each category, just have two, are very similar in that embedding space. So they bring them really close together and learn how to do that by changing the parameters of this thing. And then after that, you add a prediction head on top of it, which is basically a linear classifier. And it has been shown that it can actually train with a very, very little amount of samples. This thing overfits very quickly. I mean, it makes sense. This is a large model. We only have very few samples. So we just trained for one epoch, like very, very short. But even then, it overfits. That was a little bit too much information. So it overfits. That means perfect on train, not so perfect on evaluation. You see it on the right. It's not as bad as the small language model, but still not usable for us, unfortunately, because this is just too high. This is 10% of bad failures. And as usual, if it's not working, we know it could be working because we have a large language model that does it. It's probably not diverse enough. So we just have 57 samples. It's not diverse enough for anything to actually be learned. Probably we have a bad train eval test split. So maybe the good examples are the eval set. I heard some nice recommendations the other day in a different talk that you should choose the test or eval set in a way that it's most diverse. Also, like the train set, we didn't do that. Maybe we can try it. It could also be that the base model is just not powerful enough, and you might say, "Oh, how is that possible?" Because if it gets larger, it overfits, but not in the area of large language models. So it can be shown that if you make the model more complex, it is less prone to overfitting, which is surprising. Very different from classic machine learning. Okay, so final one, and I think I gave away my secret yesterday. Performs well, but with a caveat. So we developed it. That was a really nice experience, but only looking at the train set. I've never looked in the test set, not once. I have no idea what's in there. Looking at it and then coming up with the regular expressions, and only at the very end we ran the test set and still don't know what's in the test set. The code, I will show you the code in a minute. It looks definitely overfitted, and it's also a nice experience to look at code and say, oh, this is overfitting. And you will understand what I mean. But it's looking at the metrics, it's not. But if you look at the code, you say, no, this is not going to work. As I said, metrics, perfect. Now, code. We had a little bit of problems because we didn't know what to translate and what not to translate, but I think you will understand. So this first line here, it says, is that Sauerstoff, which means oxygen, and we're ignoring the case in the text, Boolean, yes or no. Then sometimes, German is that language like seriously that you can create words that are infinitely long, you know that. You just put words together, seriously. And there's also something like Sauerstoffüberwachungsmonitor, which means oxygen saturation monitoring device. And this is something else. This is not oxygen. This is a device for measuring oxygen. And in that case, if something starts with oxygen saturation, it's not oxygen. But if it's oxygen saturation itself, it is oxygen. So this is what I found out. This is what I coded in. Well, you see, this is basically just 2 lines of regex. And even for regex, I mean, no one understands regex, but those you still understand. So it might be in good code. Not so sure. And then you combine the two and you have the prediction. Who would say this probably generalizes? What do you say? I mean, I have no idea. My guess is as good as yours. You think that's good? Would you go into production with that? No, you wouldn't. Not a single nod. No. We also don't dare. Why not? Because of the overfitting.
I wouldn't say it's overfitting. It's just so simple it cannot really overfit.
You don't think so? Okay. Okay, but that's a good point. It's so simple. How can it overfit? Well, it's possible. I don't know. Would you put it into production? All right, there you go. Maybe you have a system that's very expensive. It's proven to work. This is so inexpensive. So, I don't know. Maybe I try it one day. Final one. I think we're good with the time, so I'm happy. Named entity recognition. It finds entities in text. It's also large language model. We use this one. Again, German. Pretty good. Easy to install. Nice. Would run on the CPU. You make it run on GPU because that's much faster. It runs really fast. Works well on German. Works well on international names. And sometimes not. For some reason, some Greek names don't work. I don't know why Greek, but don't work sometimes. But right-hand side, of course, it doesn't work for this task because it's trained on this data set, and that data set only annotates persons, locations, organization, and miscellaneous names, obviously, because it's general purpose. So no chemical substances like Sauerstoff. I know that there are people around who are chemists, maybe they have a clue for me, but this is what we found, but I haven't tried. So there's a specially named entity recognition model, we haven't tried it, that is trained on multilingual biomedical data sets that contains chemicals, diseases, species, genes, proteins, cells, and everything. Has anyone ever tried it? No, I haven't tried it myself, but I will later speak to the chemist's people, so maybe they can help. So that's not suitable here. So this is what we saw. So we have a medical report. It comes in as a document. We put it into our routing component, which finds out, oh, this is oxygen report. handle it this way. We send it to a specialized GenAI system, and for us, we define GenAI system as the model plus a predefined prompt. Because task that we're doing here is always the same per system. But there are other use cases. So in the thing we just saw, the request is always predetermined. We always do the same. What varies is the document, and it's handled by a complete AI system. That means at least language model system prompt. Sometimes we attach sources of knowledge, sometimes we attach two calls, but it's a complete system. On the other hand, if you're not automating, but you have a dialogue, you don't know the prompt upfront. You don't know what the people want from you, right? That's a typical thing. So that's totally open. So the routing challenge is different in that case, in the sense that you're not routing to a complete system, but rather to a specific model. And the two use cases are brought, look like this. The first one is, does it contain personal identifiable information? And the second test that we do is the request, is it complex or not? And this is used to determine which language model to use. So those are really for ones we use right now, unfortunately. But if it needs to be, the other way around. If it contains personal data, we must process it on-prem. That means in the Llama models. And if it's complex, we need to use the large model. So this is how the matrix on the right side works. So cloud is much more convenient because we don't have to run it, it's inexpensive. Microsoft takes care of it, but sometimes we must not use it, and sometimes we can use the small model, which is less expensive and faster, and sometimes we have to use the large model. And what goes in here is not the document or the text, but the complete prompt. So someone wants something from the system. Okay, so how do we do it? Personally identifiable data. This is what I explained. This is what we want to know on-prem or in the cloud. And the approach is actually, in this case, named entity recognition. It works really well. Sometimes it messes with Greek names, unfortunately. We don't know why. But it works really well. And then we also, again, use regex. Because there's special numbers for the insured members. There's special provider IDs, which we also have to find out. And this works really well, surprisingly. So, first challenge, addressed. Second challenge, this is not completed. This is something we do. We have an approach. It's not working well right now, so we would take recommendations. And in this case, the challenge is this a hard request? That's hard to solve, right? How do you know it's hard? How do you know it's not hard? What would be your approach? Any ideas from you? How would you do it? I'm not sure you do the answer because maybe you have something better. Probably you have. You have.
You try to use a simple model, a small one, and run it several times with different frequencies and see the stability of the answers. And if the small model is unstable, then you delegate to a large model.
Good. Yes, that's good. Different approach. I will show you my approach now because I think I owe you this. So we have a set of sample prompts. We know it from our users. What are they asking? And then we use the large and the small models to generate an answer. And if the answer of the small model is as good as the answer of the large model, we suppose it's not complex because the small model is able to answer it. It comes with a lot of caveats, and we haven't it working yet. We don't have a lot of samples. Again, always the problem. And then always, how do you decide if it's as good? And we again use the language model to say, is this answer as good as this? Which feels a little bit weird, but that's the approach. So again, we generate data. We again train a set fit model with a binary decision head. Simple or not. I think that's a good approach. Should it work? I mean, it's not working for us yet, but...
Are you doing any post processing on response that you're getting from the developer?
No post-processing. Just getting the response, just putting it into like a judge system. That's again the large LLM asking, is the response from the small one as good as the response from the large one? Oh, and we are also putting in the request so that it knows doesn't match the question. Maybe we should have what we were doing. Anyway, so far not working, but that's the approach. And there's other approaches for Microsoft doing the same thing, but for their models, so we cannot use it, so maybe it's a good approach. What else? Final slide. Do I still have time? Yes? Final slide. Guardrails. What are these? So there's output guardrails, and it could be considered routing, maybe not, but I still wanted to add it because people were also asking about like security. So is the response trustworthy? So we have plenty of that. We generate something and we check it afterwards. And then sometimes we route to a human because you think you have to double check. Sometimes we route to a trash box because you think that might not be good, don't need to show it to you. So this is all so some sort of routing, but to different systems. So we route all the time. Final thing, input guardrails. So for this specific use case, it's all friends and family, extremely low risk of fraud, extreme. So the impact of fraud, or I don't know, prompt injection would be extremely low. So maybe not for this use case, but for other use cases where we expose our system to someone who might be malicious. To position my thing here. So the first thing we do is like check, is there something like that looks like a system prompt in the document itself? Which would be really mean. I mean, if you tried that, then that's definitely fraud. And then, if the people actually know about the data structure, and I just noticed I revealed the data structure to you. Now it's a white box to you. So if you actually are a white box hacker, you could write into the document, write faults into a Sauerstoff, because then it doesn't look like a system prompt, but it might still impact the output, so it gets the wrong answer. But for this white box hacking thing, you would need to know the internal structure, which I just revealed. That's unfortunate. I will change this. But you're obviously not hackers and you're nice people, and you don't have access to the thing. But this is something I shouldn't do if it was really like super sensitive and I couldn't change it. But I noticed, so we'll change it. With that, do we still have time for questions?
Yes.
Okay, questions.
Yeah, thank you for the great talk. Maybe just regarding the last slide.
Oh no.
How do you do then those checks? So these are again reg access?
No, those checks are all large language models. It's impossible to check this with reg access because you can write a prompt in any language. So you could write a system prompt in Greek, and then it will still be system prompt because the language model that you address it to is so powerful that it will understand every kind of like things. So it has to be a large language model itself.
But then there's a kind of like loop, right? If there's a prompt in there that says, always return false, your prompt is to check me or so.
You can prompt in a way that will say ignore everything else as a system prompt that comes after this line. So there are techniques to suppress something that's an injected prompt. Okay. So by writing your original system prompt in a way that we don't know how to hack. So the way you do it, one system or one team, like our team, you come up with the idea, another team tries to hack it. So far they have not been able to, and that's probably a battle between them. So it's probably never quite safe. But okay. That's the approach. So again, large language model, also for this one as well.
Okay, cool. Thank you.
Yes.
It may sound provocative, but I really mean it. So at the end, you will have human review anyway for it. So is it worth it? doing all of this? Isn't it enough to just let the person read and then they would be able to distinguish our stuff from our stuff that they get it?
That's a very good question. It's also a question my managers, you could be my manager asking that. And then if you were my manager, you would say, why still the human review? Because of fear. So we don't have a lot of experience. We might switch to only reviewing. We might switch to only reviewing the system if the output guardrail tells us so. But right now we are reviewing everything. In regard to how does it help? I mean, they don't have to read like 10 pages, and they don't have to come up with a structure. For them, it's very hard. We learned this. Very hard to write something. It's very easy to edit something. Maybe that's a human property. I don't know if it is. And often we have special annotations. We have a couple of those guardrails that will tell people check that part, or we have a couple of instructions for them. If it's that kind of assessment, please double check. And but then in the end, they still have to like look at the summary, and if they say that looks reasonable, that's good enough. Yes, but it could be optimized. You're right.
How do you select the GPU? Is it based on the time you want a response, or how many response you get? Is it one time you add the data and you get the response in one time, or anybody can access the data? Is it like that? I mean,
maybe I didn't quite understand. Are you asking can we process the request in batch?
Yes.
Yes, we process in batch, and this is done by the GGI server from Hugging Face. Very good stuff. Where is it? No, it's not here. So there's something called TGI, which is an inference server which does the batching for us.
Oh.
It's still not on the slide. I don't know how to get to it, but it's called. Oh, it's on this slide. So this one.
Yeah, and how do you select the GPUs? It's based on the performance or the time? Like
So once you access this, maybe I still didn't get the question, but once you access the inference server, you already make choice which GPU to access. But that's not the question, right?
Yeah, I mean, that was the question, because when I want to know how do you choose the GPU?
Oh, now I get it. Okay, so how do I do the routing? Yeah. That's one call to a language model. We get back the result, and then we do another call.
One at a time?
Yes, one at a time. I mean, one at a time for that sequence of I don't know, for the flow of the system one at a time.
Okay.
Well, are you asking, could I parallelize?
Yeah.
I could, yes. But it's not time sensitive, so this runs offline in a batch. So, but that's a good point. If it was online, we would parallelize a lot of calls.
Yeah, then you don't have that much of expense, maybe.
You don't have what?
That much of expense on the GPU.
Yes, exactly. That's a good point. I never thought about it, but good, yes. You're right. Are we not running out of time?
Yeah, you have one more question.
Okay, perfect.
So thank you for the presentation. It was interesting to see that you could not use a dedicated NLP system such as the SPACY-based pipeline for entity detection. But actually, last year at EuroSciPy, there was a presentation by Ines Montani, and she did I think she advocated for the fact that sometimes LLMs are much more powerful to deal with text data, but they are expensive to run. So if you can use them to try to generate or annotate training data for much smaller neural networks, such as the ones that are implemented in SPACY, and then they are much cheaper to operate. I was wondering, have you tried this approach? Why not try to label or augment your training set such that you can train a supervised model that works better?
That's a good point. And that would also help us with the limited set of training data, right?
Yes.
But how do we do it? I mean, if you have a fixed or well-known feature space domain, you sample over all of that. How do we sample over free text? We don't know how to do it. But You mean like maybe you should try that? I mean, come up with something, shuffle a little bit around, copy paste, have fragments. That's a good point. Sounds good.
Actually, you can use the LLMs to ask it to paraphrase your training documents to generate new versions. You can translate and back translate and do this kind of things.
Right, but it's like the technical detail, the medical detail, or like how many medical things, that there are thousands of them. If you don't cover them, maybe it's not good enough, but I like the approach. I probably will try that, and maybe next week. Thanks for the input.
Thank you so much. So we have 4 minutes to move around if you want to switch places, short break, and I'm going to have the next speaker. So.
I have a quick question.
Yes,
I didn't
sure.
know that. It's like about the privacy thing, actually. So there are those like trusted cloud platforms, confidential computing, stuff like that. Is it too expensive or it's still prohibited by law?
It's okay. I will.
You mean like
Azure confidential?
So here's the HDMI.
when a US government organization wants to know something about any of us.
So we'll go take the
So
water
they-
for you.
Okay. Even if it's a daughter company,
One
it's German,
second,
but
how
belongs
can
to
I pronounce your name? It's Ada Bull.
collect data from me.
Well, actually, I'm
We have the
Czech
data is
speaker, so I don't know how
be like a medical
pronounce it
system of yours.
correctly in German.
Like all the stuff.
Okay.
But I usually use BAM.
That's
Okay, Ada Bull.
It's very unlikely, but still, if it happens, you are a customer. Not good. So this is why we don't dare to do it. We might at a certain point dare to do it, or I don't know if the government changes. Trump makes it worse. You understand? Yes, yes. So that's why we're not doing it. But some people argue we should take the risk. But then we managers to take the risk. Our managers don't take risks. And that's a reason. It's like this. So it's they have to, like Brexit. Yes, yes. And if they ever happen, how would we know? But we know that they could.
Fakt, co s tím monitorem tady?
Außer den einen Schritt, den ich euch gezeigt habe, wo ich dann so, da kannst du nicht. Das ist total dumm. Das ist so ein bisschen Falkenbrot. Der kommt auch ein bisschen Falkenbrot, der.
Thank you.
So we have 20 minutes, which means 50 minutes of speaking and 5 minutes for question. I will show you a sign that 5 minutes is left to the question time. So 10 minutes after you started, you can take the question time. So after I tell you the time is up, you still have 5 minutes. But after that, you need to finish. So if you want to have a question, you need to finish when I tell you it's like time.
Okay.
Other than that, it's okay. Okay, so
Okay. Let's start. Okay. So now presenting will be Ada Bull. Yes. And Ada is a Rust and Python developer. She is a tool builder in various areas, including schedulers for clusters, tools to support AI experiments, or a tool to create slides. She is also an active contributor to several open source projects, and Ada has a PhD in computer science.
Thanks.
Do you hear me?
Yeah.
Fine. So I work normally in supercomputing center, and I'm working on things like schedulers. But also last 2 years, I have spent 2 years on AI safety experiments, and I spend lots of time with the Jupyter and doing some interactive programming. And I would say I'm very dissatisfied, but this should not be the talk about how bad the Jupyter notebook is. I would like to show some way how we can improve it. So I would expect that everybody here knows how it looks like Jupyter notebook. Is there someone who never saw a Jupyter notebook? Okay, but how it looks like, you have some code, you evaluate the code, you get the result, you evaluate the code, you get the result, you evaluate the code, sometimes you don't get the result, you evaluate the code, get the result, and so on. So on some abstract way, you have the code and output, you have the code and output. And if you are using it in this order, it's totally okay. Like if you are reading the documentation and you have some tutorial like Jupyter notebook, it's totally fine. But in interactive programming, at least for me, and as I'm used to in past, I have spent some time in Smalltalk, which is heavily interactive, and I would say that this kind of structure is completely like constraining. It's like writing a document. If you are just the reader, you are executing the cells and producing the outputs, then you are a reader, you are not a programmer in the time, and it's totally okay if you are reading the documentation. But if you are creating something, I think that usually, at least in my experiments, it's not like creating a document. I'm reevaluating the cells several times, I'm reevaluating the cells in different orders, and then the structure is completely like lost, that it doesn't make any sense. Like for me, the interactive programming in this non-tutorial way is like creating a sculpture. Like I need a code that modifies my memory. So the memory is this sculpture, and I am changing my memory of the computation to the shape I want. But then this doesn't make sense. So let's try how to fix it. And one thing is to break this structure. So the simple thing what we can do, just split the code and outputs. Because for me, evaluating the code is like doing the change into the memory, and then I have an observation. But the observations has some ordering, some chronological ordering. You observe something in some time, and here in this original Jupyter notebook style thing, your outputs are not ordered chronologically, but in the order how you evaluate them. And so it's not an observation; it's just random order usually. So I am saying let's split it. It should not be connected. This is the code, this is the observation. And I have implemented an experimental tool, I will talk about it more, it's called TwinSong. It looks like a Jupyter Lab basically, it's running in the browser locally, but because I don't care now about this thing, I will just zoom in. So here we have some cells and there will be outputs. So if I will evaluate the cell, I will create a first run, and I have an output. If I will evaluate the second cell, I have an output. But if I will now evaluate the first cell, I get an output. But I didn't forget, this is now chronologically ordered. And I did not forget all previous results, because this is my observation. I do not want to forget the previous results. And this is what forces me, the normal Jupyter notebook forces me to forgetting the old things. And I have to just duplicate the cells just because I want to preserve the results. So for me, it does not make sense. I can also evaluate again this cell. Then I will modify this 1 to +5. So what will happen? I will go from 11 to 16. But if I will go, maybe I will go to the toilet for the coffee, and then I will return, and maybe it looks quite weird that like from 10 I get to 11, then from 11 to 16, that this means that this cell was evaluated. But still, I preserve all the history because I can click on this code and see, okay, this cell was evaluated because there was x plus 1 and I get 11. Now there was x plus 5 and I get 16. So it's not only chronological order, it remembers all the code was executed. So I can reconstruct how I get there. And for me, this is one of the biggest problems of the Jupyter notebooks. I get in some random state and I don't know when actually I am. So, but this gives me a way how I get somewhere. And also the document style thinking about the programming makes you somehow forget about other things. So for example, as we have split the code and outputs, we can have, or these kernels, we can have multiple kernels. So I can click on this plus button on the top and I can start a new kernel on the same code, and I can evaluate the cell, and it's completely different run, but the original one is still active. I can just switch the tab, I can evaluate the cells. It's not released yet, but it's quite experimental, but you can also fork the kernel. So I can load the data, get somewhere, and then the fork and have different status, and I can modify these sculptures in a 2 different ways. And so this gives you much more flexibility. I can start more arbitrary many runs. I can stop each of them as I want. For example, I usually, when I am experimenting with this tool, maybe I have some long-running thing at the beginning of the Jupyter Notebook, and maybe I'm also experimenting in different tab with some other code, so I can develop the same code even some long-running experiment is running. So far we had some opposition for this idea is okay. Sometimes I just want to have some temporal projection of my memory, like temporal look on how it looks like the state, and so I need to create maybe the cells I do not, or outputs that I do not care that much. But for me, this is also the drawback of the document-like approach. Just to see how looks your memory without modification, you need to do an action. You need to run a code. And I believe this is wrong. If I just want to see how memory looks like in interactive programming environment, I should be able to look at it directly, not without doing an action. Action should be when I want to change the memory or do some very non-trivial projection. So if you click on this button on this workspace, you will get here. So let's have this example. If I will evaluate this cell that creates some data class and dictionary, I will get this view of my memory. So, for example, here we created a data class, and P1 contains some instance of this data class. It has some name, age, and so on. This data is dictionary, and we can see the keys and values. Actually, it's not written here, but because we have dynamic data, we can derive automatically that it's dictionary, not ordinary dictionary, it's from string to int. So even if we did not specify it, because we see it in the data. So far, we have speak only about this right part. But once we do not think the code and data together, we can also look on the left part. And normally, if you do normal programs, you usually use the nested structures. You have directories with the modules and submodules and files there. And in Notebook, why we are basically throwing this away? In Notebook, everything is linear, no nesting. But it's a still program. It has natural properties for nesting. So, for example, here I can have some initial phase, maybe some definition, some main computations separated to phase 1, phase 2, maybe some post-processing. So it's very natural to organize it as a tree. And it's also how you use it. Sometimes you need to repeat the same cells, so to recompute the same cells, or still repeatedly the same sequence of the cells. But this supports, the TwinSong supports, like you can evaluate the whole subtree. So if you have it in the subtree, you just evaluate the subtree, and you don't have to go repeatedly from the cell 1, cell 2, cell 3, and so on. And so if I just don't care about the init, I will just run in some initialization tree, and I don't care about the individual outputs. And then maybe I can just go to the cells that I'm really interested in. For this subtree is for organization purposes, but we can make even a step further. For me, the biggest problem in the Jupyter Notebook is that it has just single global space. if someone will deliver you a program that just uses every variable is in the global space, you would probably consider it as garbage. But why it's tolerated in Jupyter notebooks? TwinSong supports the memory scopes. If I have a tree structure, I can have a memory scopes. This bubble means that this subgroup has a memory, its own memory scope. So here, if I will evaluate this x, I have a global variable x with value 10. If I will evaluate this cell, it's not now, it see, because it's under the global space, it see the value of the x, but the new variable is created in the new subspace, the completely separated scope. So if I will now try to evaluate this print y, it will be an error because this cell lives in the global space. So I cannot accidentally pollute my memory just creating, because it's not nicely prepared notebook. I'm doing interactive programming, so I make a typo, I will create a variable accidentally, and so on. And I think it's very important concept. Have a separated memory scopes. It's completely natural in Python, in other languages, but it's somehow not possible in normal Jupyter notebooks. If you really want, you can also modify the other scopes from some different scopes. All these things can be nested. So the nodes in the tree with the private scopes can also have the nodes with the private scopes and so on. So this was a TwinSong. All I have shown you is implemented. You can try it, but it's still experiment. So for example, matplotlib is not yet fully supported, and I mostly focused on the user interface experiment. So it's not probably useful for everyday production, but you can verify if the idea makes sense. Just another few technical comments. Yeah, there is only Python kernel. We cannot reuse the existing kernel protocols because it has lots of other features, so all kernels cannot be reused. And also, it has Git-friendly format. I don't know if you have ever used the notebook with the Git, but you just evaluate the cell and you have a conflict. You need to use some external tools. But TwinSong version the files, like the code, is in one file. Each run is in one file. So if I just want to version the code, I will just version this file. If I want to version the selected runs, because they are important, I can just version these files. I can remove any run just by deleting the file. So you don't need any other external tool. Also, the backend is written in Rust. I'm mostly saying it because it's much more fun to contribute, so this is somehow like calling for the contribution. But for the perspective of an ordinary user, since the kernel itself is written, like 99% is written in Rust, it does not spawn any Python thread, any Python structure, so the kernel is very quiet and like clean. So you don't conflict, your libraries does not conflict with the libraries loaded in the kernel. So this is the TwinSong, it's open source. So if you will try it, I will be very happy for feedback. And yesterday there was a lightning talk, and there was the tool, like demonstration of the tool creating the slides in Markdown. And we are on the Python conference, so I'm also adding extras. This is my tool for creating the slides in the Python with the Rust backend, so it's very fast, and it produces PDFs, so you will not have this problem like scroll bars when the size of the screen is changing and things like this. So, but yeah, this was the most important tool here. I'm ready for questions.
Okay. Thank you so much for a very nice presentation. Now we have 5 minutes for questions.
Thank you for the presentation. I might have missed it. When you create a subgroup to have a local memory, are you allowed to get out and later re-enter the subgroup? Or would you have to go back in the notebook and nest the cells there?
I'm not sure that I understand the question.
So here you enter a subgroup, right? Could you then, once you leave the subgroup, later go back to it?
Yeah, if I will ever, on this subtree, if I will create more cells in this subtree, then all of these cells will be in this subgroup, and they will see the Y.
Okay, so you would have to add cells inside.
But or I can modify this one, but yeah. The visibility of this subgroup is defined by this code lives in this particular place. Like in function, you have variables that just is seen from this function.
Okay, thanks.
Thanks for the question.
Is there any way to like directly compare outputs between run 1 and run 2, say?
Sorry?
So if I create a large array, then maybe change the code and want to run it again in a different run, is there a way to like make sure that they're still equal, or see if any changes have occurred between them?
Yes. So far, the runs are separated. What I have in my roadmap is like you'll be able to send the values between the runs, so you can just send the run. Send the value to the run and do the normal equal operation. But yeah, I'm also thinking about some kind of diff from this vision, so you can, if you have, it's hard visually to do it if it's 1,000 elements. So I also want to create a diff. So if you have like, now you see that 2 cells are the same, but I want to have like just on a single click you will see how it differs from the previous evaluation. But it's not implemented yet.
Very quickly, can you show us your link to your repo or your this one? Thank you. That's just one gate.
Simple question. I'm a beginner user for like Jupyter notebooks. Can you also is it possible to add markdown cells as well, or strictly code cells only?
I think, not yet. I would like to add it, but at least for my workflows, I almost never use the markdown. Because for me, this is, if I would write a documentation like Jupyter Notebook, then markdown is really good. But for I'm doing experiment, I do not want to, of course I write a document or comments, so it makes sense them commenting your code, but there is no technical reason why we should not add the markdown there, but it's not priority for me.
Okay, thank you.
Thanks.
I have a question about the implementation. So, is it possible to reuse some of the Jupyter code, not to implement it all from scratch? Because, of course, we're working for this for many years, and it's hard to create the tool with the same functionality from scratch. So,
again, not yet. Actually, it's almost done. I didn't just have time to finish it before the conference, but like. Almost finished feature is the import of the Jupyter Notebook to the TwinSong, because it's easy. Like in the normal Jupyter Notebook is some kind of weird subset of the TwinSong notebook. You have just single run and flat structure, so it's easy to import. It's slightly more difficult to export because there is this function with these memory scopes, so it's not directly exportable. If you're using memory scopes, you cannot directly export it to the Jupyter, but Jupyter cannot be trivially imported in the TwinSong notebook.
Actually, the question was more about the implementation of this TwinSong framework. So, can you use a Jupyter code, like Jupyter source code?
So far, you mean that like you print something with HTML and it's visually.
Yeah, how you implement this TwinSong, how you display cells and everything, how you run them. So there is a lot of backend in Jupyter. So is it possible to use this?
It supports some of the parts, like if you have this HTML wrapper, so it will be that is used in Jupyter, so it will be rendered correctly. But there are some other features that is not implemented. But my goal is like. At the end, you will just take almost arbitrary library that works in Jupyter Notebook, and you will have a proper display.
Thank you again for your presentation. So, small applause, please. Yeah. And that's all. Now we have a lunch break. Yes, you know where the lunch is, I suppose, now. So, yeah, see you at lunch.
Good job.
Thanks.
So, your first day here? Or
Second day.
The second day. Okay, so you know where there is lunch and
Yeah,
everything, right? So don't worry. You don't have to, hurry yourself now. Lunch will not go away.
Okay, thanks.
Yes.